Okay, so welcome to part 9 of Negative Sequence Made Easier. This one's going to be over the GE869, and just as a note, this is going to be the same as the GE469. They both perform this in the same way. They both just show this a little bit differently, but it is essentially the same calculation. There's really no difference, especially if you follow the way that I'm going to do it. And so this is the equation. Again, just like the 369, we're not going to go over time delay. It's just a definite time delay. There's no curve or anything to calculate. So this is our equation, and like I said, we're gonna keep all balanced angles. We're gonna stay at FLA, and then we're just gonna vary one current magnitude, which is gonna be IA, above FLA, and so that this way we can simplify our math. And so because of that, if you read in here, the A factor, whenever I average is equal to or greater than the FLA, then IA is just 1. Otherwise, the A factor you have to calculate, and it's how to it shows how to do it right here, but we don't have to worry about that. So A is just going to go away, and it's just going to be that. Okay. As I said, they're both 469 and 869 are the same. So here's our equation, and these are our parameters. Like I said, FLA. We're going to start at FLA for all three for magnitude. Angles are going to be balanced. And then we're only going to, B and C are going to stay the same the whole way through the test. And you're just going to ramp up A phase magnitude, okay? That's all we're going to do. So A factor goes away. This unbalance right here is setting in the relay. It's going to be like 20, which is the default. Honestly, that's what the reason the 100 is here for. So I would just write 0.2 equals I2 divided by I1. Okay, I actually kind of like calculating this one. I think it's pretty fun. This right here, the IA goes away. And here's our I1 and I2. So let's go ahead and put these in here. So I'm gonna do this long format. 0.2 equals, and our I2 is going to be all of this right here. So this is IA. I'm just going to write a big line like this because we're going to need space. IA plus IB with a phasor compensation of alpha squared, plus IC with alpha, all divided by 3. And then the I1 is right here. And, this one's divided by 3, but we're dividing by I1. So really, we could just flip this fraction. So this is going to be 3 on the top instead of on the bottom. And all of our positive sequence calculations are going to be on the bottom. So it's IA plus IB with alpha plus IC with alpha squared, okay? And that's all in parentheses. Now, when you look at this, you can just get rid of these threes, right? That makes it easy. And then for the next part, let's go ahead and do some quick compensations. So we're going to do 0.2, and I'm just going to leave it here. IA, I'm just going to rewrite this, plus IB alpha squared plus IC alpha divided by IA plus IB alpha plus IC alpha squared. Now, let's think about this for a second, because we know what some of this right here is and this right here. So we can simplify this formula even more, just giving a little bit of thought to it. So IB is going to be equal to FLA, right? IB is going to be, the magnitude is FLA the whole time, and a phasor compensation of alpha squared means you're just going to add 240 to it. So if IB is already down here and we add 240, it's going to go up here, okay? So that's what IB is going to become. This is going to be IB. And then what's going to happen to C? Well, C is going to start up here, and we're going to add alpha. So we're just going to go down to the bottom. So C is going to be right here. And if you watch the IQ 1000, you'll see that it's the same compensation. These are both going down and up the equal amounts. So the vertical axis will cancel out, and you'll just be left with one FLA in the negative direction. Okay, so both of these can actually cancel out. Actually, what I'll do is I'll move this off to the side and not scuff that out just yet. So this is going to be equal to IA plus, or it's going to be a FLA at a negative 180, or you could just do minus FLA. okay, which keeps our angle at 0 degrees. And we want everything to be at 0 degrees because we're trying to solve for IA at 0 degrees. So let's just keep it like that. And then what's this right here become? Well, this is our positive sequence portion. And IA, we're not going to do any compensation for that. But we do have this that we could figure out. IB is down here plus a compensation right there. So IB is going to result right there, which is 0 degrees. That's perfect. And it's going to be FLA. So this is just FLA at an angle of 0 degrees. And C is the same thing. It's up here, but it's got alpha squared, which brings it out to here. So this is also FLA at an angle of 0 degrees, which becomes plus 2 FLA. And we don't really need to put the 0 degrees because if we keep everything in 0 degrees, then we don't need to write it down. So now we've got this on the bottom and this on the top. So let's rewrite that up top. I'm going to clear some room. So I'm going to write this as an unbalance here instead of the 0.2, which is the default setting. If you have a different setting, just plug it in. Just remember it is times 100, which equals, it's going to be 0.2 instead of 20 like you see it inside the relay. So this will be UB, and the first thing we'll do is we'll distribute, or I'm sorry, we'll multiply both sides by the bottom down here so we don't have a fraction anymore. So this will be UB times IA plus 2FLA equals IA minus FLA. All right, so now we've gotten that. The next thing we'll do is we'll distribute this UB to both. So UB times IA plus 2 UB FLA equals IA minus FLA. We'll add FLA to both sides. That'll get this to the other side, and we'll subtract UBIA from both sides. That'll basically get this term over here and then this term over here. So that way we can get IA by itself, okay? So what we'll have is 2 UB FLA plus this FLA equals IA minus UB times IA. What we'll do on the left-hand side is we'll divide both by FLA, and so this will be FLA times 2 UB plus 1 equals, and on the right-hand side, it'll be IA times 1 minus UB. That was sloppy. Then we divide both sides by 1 by UB. 1 minus UB. So that'll just have IA by itself on the right-hand side. So I'm just going to change this to IA equals the left-hand side, FLA 2 UB minus 1 divided by 1 minus UB. Oh, sorry, that's plus 1 on the top. There we go. So this is the equation that you would need to solve for anything. And so the default setting is 0.2 or 20%. It'll be 20 UB in the relay, which is, that's what the 100 is here for. So if we had that, this would be FLA. I'm just going to bring this to the outside. So you're going to start at FLA and you will increase it to, well, what magnitude would it be? It'd be 2 UB, which is, UB is 0.2. So 2, 0.2 plus 1 all over 1 minus 0.2. And this is going to end up becoming FLA times, we have 2, which is 0.4 plus 1, which is 1.4 divided by 0.8. And this equals 1.75 times FLA. Okay, so if your FLA was 2.5, then you're going to increase A phase. All three will start at 2.5 amps. You're going to increase A phase from 2.5 to 4.375, and you should get your pickup there. Okay, so hopefully this helps someone understand how to perform the current unbalanced test on GE 869. Remember, it is the same as a 469 relay, and it's this right here. Just make sure that you follow the standard procedure of keeping all of your angles balanced. Stay at FLA and only raise one phaser to whatever you calculate the final pickup to be. So hopefully this helps. Thank you.